Welcome to clickmyproject.com. Let us discuss about the copy move image forgery reduction. Let us discuss about the abstract of the product. So in our proposed system we are going to propose a method of our copy and move forgery reduction which can sustain various pre-processing attacks using combination of DYWT, that is a dietic wavelet transform, and scale invariant feature transformation, so that is a shift feature extraction, with BFSCN, so that is a broad first search neighbors clustering, and CFA. So CFA means color filter array feature. So these are the main important process in the proposed system. And then in this process, first we deduct the forgery part, so that is a DYWT, dietic wavelet transform, is applied on a given image to decompose into 4 parts, that is LL, LH, HL and HH. So since LL parts contain most of the information, so that is a LL means that is like a linear property, so most of them contain information, and we intend to apply shift. So shift is a scale invariant feature transformation on LL part, which combines broad first neighbors, so that is a BFCSN clustering and color filter array features. So shift feature extract the key features, and then we can make the BFSN cluster of those key features, and then we perform cluster matching and CFA features. So BFCN clustering algorithm is applied to deduct multiple copied areas in tampered images, so that is called tampered images, in order to distinguish original regions from tampered imaging. So we take a CFA feature, so that is a CFA features means a color filter array, and also we take a features into concern to discover the edges at the copy of the region. So finally we calculate the performance and analyze the overall of the process. Let us discuss about the flow diagram of the process. So first of all, we select the input image. The input image is like should the remaining of the tamper image like that, and then pre-processing. So in the pre-processing step, we use the glossing filter to remove the noise of the process, and then apply the DYWT. So DYWT is a dietic wavelet transform on the pre-processed image. So we applying the dietic wavelet transform of the pre-processed image, and then calculated the LL, HL, LH and HS of the part. So and then applying the calculating the feature extraction. So we applying the shift feature extraction on LL part. So absolutely for the LL part of the process, obtain the shift feature descriptor vector. So and then calculating the apply BFCN clustering for detecting multiple copies of the part of an image. So calculating the clustering of detecting multiple copies to calculating the image of the process, and then it should be calculating the cluster matching. So how the region is will be calculated for the first input images. So and then the difference between the original region and the tampered region using the CFA feature. So that is a color feature extraction of the features. Output image marked in the forgery region. So finally calculated which will be the forgery region, that is the original region and the tampered region. So most of the process calculating the tampered region, because whatever it may be used, so tampered region it's highly in the process. So calculating the particular tampered region by using the input region of the process. So whatever it may be, so DYWT is applied to the pre-processor. DYWT is important in the pre-processed image, and then LL, HL, LH and HS of the part. So SIFT is used in the feature extraction on the descriptor of the vector. So apply the BFSN clustering for detecting multiple copies of one. So like that multiple forgery images are presented in case. So we calculating the multiple forgery part of the images. So clustering is an important concept to calculating the part of the images, and then we calculating the SLIC segmentation. So let us discuss about the SLIC segmentation. So in the SLIC segmentation, the images were segmented with the help of this simple linear iterative clustering algorithm. So the SLIC algorithm segments the images based on the block size. So determine using the DCT transformation. So SLIC using the same compactness partner. So for superpixels in the images. So if the images is smooth in a certain region but highly textured in others, SLIC produces smooth regular superpixels in the smooth region and highly calculated by using the plot of the process. So finally calculating the output image mark the forgery region. So process the images were over segmented with the help of this simple linear iterative clustering algorithm. The SLIC algorithm segments the images based on the block size determined using the DCT transformation. SLI uses the same compactness parameter of all the superpixels in the images. So if the images is the smooth certain regions but highly textured in others, so SLIC produces smooth regular region superpixels in the smooth regions and highly irregular superpixels in the texture region. So it become tricky choosing the right parameters of each image. So in particular, SLIC performs local k-means clustering, where the search space for a particular for a superpixel is restricted to local neighborhood around its center. Finally, calculate the performance analysis to calculate the true positive, true negative, false positive, false negative, and accuracy, sensitivity, specificity of the process. So to calculating the various parameters by using the process. So these are the overall flow diagram of the process. Yeah, let us discuss about the running procedure for the process. So click the main file, so and then run. So it's take a time term to run the process. So these are all the forgery and tampered images. So selected the one of the images, so click this images and then open. So first of all, selecting this is the input image, so that is a tampered image, so I will select this image for the processing. So in this next step, so this is a DYWT, so dynamic wave transform. So that is a LL image, LH image, HL image, and HS image. So these are already I will told in the flow diagram process. So this is a DYWT, so that is a dyadic wavelet transform of the process. So and then the next figure is, yeah, this is the next figure. So this is the SLIC images for feature extraction of the process to detect the features by using all of the process. So this is a SLIC series. So to detect the edges, for example, like in the canny or edge detection of the process, and then extract the features. So that is using a SAFD. So detect the features by using the SAFD of the edge and canny detection of the process, and then BFC SCN clustering imaging. So that is a label feature point. So detect the particular forgery images to detect the label feature points. So the BFSCN of the clustering of the process of the images. So in this next figure, so in this figure that should be merged. So merge the forgery region. So this is the label feature points. What are the points presented in the particular forgery region? So this is the merged region point of the process. So these are the BFSN clustering image and then the merged region of the particular process of the image. Finally, detect the forgery image of the process. So this is the ship that will be detected. So the detected forgery image is shown in the figure. So compared to all the images, so the forgery part is detected. So and then finally we calculated the performance measure. So performance measure, we calculating the precision, recall, and information by calculating the true positive, true negative, false positive, false negative, and accuracy and precision and recall. So these are the overall running procedure for the product. Thank you for listening this video.